Testing, testing. All right, I'm on page 242, C++, continuing in chapter 6. And now we're going to look at another way to pass arguments to functions. Another topic that pertains to many programming languages, not just C++. In fact, if you have taken Visual Basic, these topics will be reviewed and actually repeated for you, and continue to be repeated for you as you resume your computer science major area of study. So there are two ways that we are able to pass arguments to functions: pass by value and pass by reference. Pass by value, a copy of the argument's value is passed to the called function. It resides on the function call stack. Changes to the copy do not affect the original variable's value in the caller environment. This prevents accidental side effects, hindering correct and reliable software development. Pass by value does have a disadvantage. If a large data item is being passed, copying that data can take a considerable amount of execution time, and it's duplicating valuable memory space. Pass by value is discussed on page 242 and in previous sections. It's what we have been doing in our program examples so far. Continuing, pass by reference on page 242 and 243. Pass by reference, the caller gives the called function the ability to access the caller's data directly and access to modify the caller's data directly. That means that the function is operating on the caller's argument and able to change its value in the calling environment directly. This pass by reference is good for performance reasons. It eliminates the pass by value duplication overhead of copying large amounts of data. But there is a disadvantage. A disadvantage of pass by value: it can weaken security because the called function can edit or modify the caller's data directly, which, if intended or unattended, accidentally or maliciously, can corrupt the caller's data value. Reference parameters on page 243. A reference parameter is an alias for its corresponding argument in a function's call. To indicate that a function parameter is passed by value, simply follow this parameter's type in the function prototype with the ampersand. The ampersand is found on my keyboard with a shift digit 7, uppercase digit 7. For example, int followed by the ampersand number. That is read as number is a reference to an int. Number is a reference to an int. In the called function's body, the reference parameter actually refers to the original variable in the calling environment, and the original variable can be modified directly by the called function. As always, the function prototype and the header in the function definition area must agree. Without checking the function prototypes or the function definitions, it isn't possible to tell from the calls alone whether either function can modify its argument. Because function prototypes are mandatory, the compiler then resolves this ambiguity. Let's look at our shared data file on page 243, figure 6.17. Dissecting the code, we're starting out with our include files, namespace directives, and then our function prototype looks very similar to what we've been doing. Square by value is a function. It expects to receive an int, and it's going to return an int. That's a pass by value. It's passing a copy of its integer parameter when it calls the function. And then we have our function prototype for square by reference. Square by reference is a function. It's expecting a reference to be passed to it, and it's not going to return anything. In the int function, and just double check on the next page your end method for main. Int has a local variable x initialized to 2 and a local variable z initialized to 4. Both are of type int. On page 244, we're going to be calling square by value, square by reference, and then we'll be ending main. So I've done a little markup here. Here's main, and I want to look at its begin end block, and I'm just going to document the end of main. You can certainly type that in your own code. I typically do. And then we have our function definition for square by value and its end block. And I have my function definition square by reference, begin and end block. So we begin by instructing the compiler through the operating system that we have included headers. Namespace directive is being used. We have 2 function prototypes declared, and we enter main. Calling main. Main is pushed to the function stack with a return location of R1. It has a local integer declared to 2 and a local integer z declared to 4. Continuing in main, we see out x space equals space. We're going to output x's value. And x's value is currently 2. Before squaring by value, and a new line. Value returned by square by value, colon space, is quoted to the output device, and we're going to call square by value. We're calling square by value, and we're sending x. X is known locally as 2, so we're sharing a copy of x's value, which is 2, to share by value. Share by value, we're going to place on the stack frame its allocation record. Return location is R2, and the local variable is number. Square by value, number is accepting a copy of x from the calling environment, which is 2, and that will be maintained as a local value. We're going to return number star equals number, so that's number times itself, and we're going to reassign number. So number times itself, 2 times 2 is 4. And I'm going to return to the R2 return location with the value of 4 and pop square by value and print 4 with a new line. Continuing with output on the next line of code, we're going to output x space equals space is x's value, which is 4. After square by value and a new line. Continue with execution in main. C out is z space equals z's value before square by value. Well, z's value is known by main as 4 as a local value. So we're going to print 4 before square by reference and a new line. And then square by reference is called. Square by reference, its signature indicates that its variable name, number ref, and that's a good idea to have a variable name with uppercase REF, documenting that it's a reference identifier name for you, is a reference to an int. So locally, number ref is known as a local alias pointing to the caller environment's variable. Well, a call to square by reference was z. So z is in main, known locally to main. So the caller's argument is going to be modified in square by reference. So square by reference accepts a reference to z, which is the caller's argument that was shared with it. It will be modified. Number ref times equals number ref, multiplies number ref times number ref, and reassigns number ref. Well, number ref is a pointer to z, and z is currently 4. 4 times 4 is 16. It returns to R3, the return location, and returns the value 4 times 4 is 16, modified z's value in the caller environment, because number ref from within square by reference is a pointer to the memory address location of z. Sorry. Better fix that. Number ref was called by z. So it's a reference and it points to z. So 4 times 4 is 16. From the stack frame, square by reference has reassigned the alias. It's returning to its return address location, and now will output its returned value, which is 16. Z is now 16 after square by reference has been called. We continue to the closing right brace of main, and that causes its stack frame to be popped from the stack, giving main the address it needs to the operating system. So main now has its return value, returns it to the operating system, and we stop execution of the program. tracing the code. Now let's execute the code. Again, this is a shared data file, so you can create your associated project. Be sure to set your project properties to precompiled headers, not using precompiled headers. Let's execute. Control F5. X equals 2 before square by value. Value returned by square by value is 4. But in main, X was not altered. We sent a copy of X. The original in the calling environment was not changed. However, Z is equal to 4 before square by reference, and Z is equal to 16 after square by reference. Z was sent as a parameter to a number ref that is a reference to an integer. So number ref is referencing Z's value of 4 passed to it. 4 by 4, or 4 times 4, reassigns the number ref value to 16, and num ref is referencing an integer, and it's pointing to Z in the calling environment, so Z is reassigned 16 after squaring by reference. All right, as always, return to D2L Brightspace. We're working in Unit 6 lesson plan for homework, projects, test information, and your due dates. All right, thank you very much.